I will be doing video number 3A. Okay, so sand is moving down a conveyor belt with angle 15 degrees from horizontal at 6 meters per second. You want the sand to enter a bucket that is 3 meters below the end of the belt. How far in the horizontal direction, D, do you have to place the center of the bucket to ensure that the sand enters it? So, this is bucket D. Sorry. This is the distance D from the center of the bucket, which is right here. This is the bucket, from the center of the bucket to the end of the belt from where the sand falls. And the distance from the belt, the vertical distance from the belt to the bucket is 3 meters. And the angle from the horizontal is 15 degrees. And so that's the diagram. We know that the velocity of the sand coming down into the bucket is given. It's 6 meters per second. So we can split the velocity into x and y components. The x component of this velocity is cosine of theta in the x direction, horizontal direction. The vertical component, the y component of this velocity is sine of theta, as this is opposite over adjacent, so that would be sine, and the cosine is adjacent, opposite over hypotenuse would be sine, and cosine is adjacent over hypotenuse. So we're given that the initial velocity is 6 meters per second, theta is 15 degrees, the initial y direction is 3 meters, and we need to find the distance of D to place the bucket. Okay, so after splitting our velocity into x and y components, we can find their values. So the velocity in the x component is 6 cosine of 15 because it's 6 meters per second. That's the initial velocity. And that would be cosine of theta for the x direction times the degree, which is 15. So 6 cosine of 15 would give you 5.8 meters per second in the x direction. Similar in the y direction, you do the same steps. You get 6 sine of 15 because it's vertical, and you get 1.6 meters per second. Now, to find the distance D, we would need to calculate the time it takes for the sand to fall from the belt into the bucket. And fortunately, we were given the initial y value for the height. And we can use the kinematics equation, y final equals y initial plus velocity initial in the y direction times time plus 1/2 acceleration times time squared to calculate the time it takes for the sand to fall into the belt. And so you would plug in, so we know that the y final is 0, wants to fall into the bucket, which is 0. The y initial is given is 3 meters, which is the vertical height. And we calculated the velocity in the y direction, which is 6 sine of 15. And we can multiply that by the time plus 1/2 of acceleration, the gravitational acceleration, which we all know is 9.8 meters per second squared, times time squared, which is the formula. And you would get this quadratic equation. Now, after factoring this quadratic equation, you would get two time values, t equals negative 0.96 and t equals 0.63 seconds. Obviously, it cannot be negative 0.96 as time cannot be negative. So therefore, 0.63 seconds is the correct time value, and this is the one we will use. Now, after finding the value of time for t, we can find the distance of D using the x component of the same kinematics equation. It would be x final instead of y final, so everything replaced with x. X final is equivalent to x initial plus velocity initial in the x direction times time plus 1/2 acceleration times time squared. Now keep in mind that in the x direction, there is no acceleration, so therefore a would be 0. And so x final, that's what we're trying to find, that's the distance D, is equivalent to 0 because the starting initial x position would be 0, plus 5.8, which is the velocity in the initial velocity in the x direction that we calculated, 6 cosine of 15 is 5.8 meters per second, times the time that we also found, which is 0.63 seconds. And you would get x final is 3.654 meters. That's equivalent to the distance from the belt to the center of the bucket in the horizontal direction. So therefore, the distance D is 3.7 meters. And that is the final answer. So this relates to what we've been learning in class because we've been in the kinematics section, and the equations that we used were kinematics equations. These two, the y and the x component. They're the same equation, but they're for this one would be for the y component. This one would be for the x component. Those are kinematics equations that we use to solve for the distance d. And recently in class, we've also been learning how velocity has x and y components. And so we also use that here. We split our initial velocity into x and y components. And so that's how this relates to what we've been learning in class, as this is kinematics.